So there are problems with remote video surveillance. One is that by the time you're looking at the video, the perpetrator's gone. And so your crew returns to work Monday morning, they find something stolen. You look at the video, well, you found out what happened in the past. There's no chance to. The solution then is to have somebody watching the video. Because you're thinking about the football game and just static. You add, but you still have a problem through piles and piles of false alarm. Have animals, trees. And so problems with with an alert, a quarter inch. What you really like to have the alerts, but it gives you an alert that's been filtered, where most of the false alarms, all the uninteresting video footage. So the solution do motion detection through the camera lens. Then we do object recognition, and then we combine these. We look of interest. Since it uses cameras will do. There's only one product, one hardware product. Supplied gauge means it's on at the and heavily a then the cloud comes metadata and time as a lower priority. Security personnel whatsoever. That's, I shall show how it works. This is the web dashboard. This is footage shot from the front of my house. These are the alerts that occurred during that period of time. Now notice that in this image we have a parked car. It's recognized as a car, but there's no motion there. So it is not an alert. This gold-colored box indicates an actual alert because you have this green outline shows an object in motion, and it's being detected as a vehicle. Right now the system is set up to detect people, vehicles, and dogs. I had to turn on dogs so that we could catch bear running around the lobby up front. And then we keep the camera rolling for an extra 10 seconds in case anything else interesting comes along. There's another car going by.
You live in a quiet neighborhood. So what are those green on the cloud? I see sometimes that there's a yellow.
Is that motion in the tree?
There.
Oh yeah, that.
The clouds?
It picks up a lot of, well, it picks up differences from the background. So it doesn't actually, this system does not track motion of any object. It picks up background difference. Well, if the camera adjusts its brightness or white balance, something like that, it can detect objects as motion. Part of a future enhancement is to either coordinate the algorithm, adjust the algorithm, or just, if it happens slowly enough, the algorithm will happen. But this camera, if somebody walks in front of a bright light, and it'll suddenly turn up the brightness of the camera because the bright light has been removed from the block from the image, and it changes the whole scene, and so you get it all over the place.
So do you subtract? So all the time you're constantly learning what the background looks like, and for every motion you're basically subtracting that background.
With each frame, you'll see this green cloud kind of shrink and disappear. So it vanishes as we learn the new background, as the cameras change its settings. Here's one a little closer to home. This is just some guy walking by. Didn't know he was on camera. Well, or did he? This is the previous one. He's looking at the camera, wondering what I'm going to do with this footage.
What kind of camera is this?
It's a AWS Deep Lens camera. So it has the camera hardware and the edge compute device in one unit. For this for demonstration proof of concept. There's me returning from a walk.
You installed your Python algorithms in the camera itself?
Yes.
Cool.
Yes, this whole, everything I'm demonstrating is just what's being processed on the camera, what's in AWS, and a web browser. So there's nothing at all running on this machine or any other computer that I operating.
Sure.
Well, the web server's running.
So
But in deployment, we put it in the
What
cloud.
web server are you using for this one?
This is Plotly, which is based on Flask. So I was hoping to get a little bit, if you guys notice the camera in the back corner, I hope. if you notice over here, it tells us which camera at that location, of course, the timestamp, the clip duration, a certainty that we found something interesting, which is a combination of the turns and a rectangle that is in motion. So notice a couple of these times in the scene. Wondering which probably just one frame. Now I have metadata in Denk. You could scooch to that frame and find the bicycle. In the past, it's been this looks like spokes or bicycle, but it's not in motion. So it won't show up. It won't cause a trigger unless something else. Apparently that's the end of the demo.
There's another one.
my Okay, so moving right along. I believe that a product based on this technology could be here. The feature set needs some added but it would need some industrial engineering product.
I have a general question. So for criminal detection, criminals usually, I get the sense, I don't know if that's the reality, but they usually get the sense that they come at night or where visibility is real low. Do you think that's gonna, I'm sure it does, but do you think the accuracy is good enough for that kind of environments as well?
Well, as far as I'm aware, most security cameras that are used at night are not actually thermal imaging; they're just infrared illumination.
Okay.
So they use the camera is pretty standard. Most camera image detection elements, like a CCD, is sensitive in the near infrared, and so all they have to do is change the filtering, the color filter in front of it, and then have some infrared emitters. And so it's not actually night vision because there's a floodlight. It's just an invisible floodlight. So in that case, right. Good, the Plotly dash. And someone else is asked. If you have a strange
influence in a fire exactly
I had to run the deep lens camera. Actually, the reason this person angles to be offset from essentially used by and stopped. And
Feature trade.
it was a